Have you ever wondered how the towering peaks of the world's largest mountains came to be? Our journey begins with a concept that is as fascinating as it is complex: plate tectonics. This is the grand puppeteer behind the birth of mountains. Imagine the Earth's crust as a giant jigsaw puzzle, composed of several large and small pieces. These pieces are called tectonic plates, and they don't just sit idle. No, they float, slide, and collide on a semi-fluid layer beneath them, known as the asthenosphere. Now let's delve a bit deeper. These tectonic plates aren't all the same. They're classified into two types: oceanic and continental. Oceanic plates are denser but thinner, while continental plates are less dense but thicker. And here's where things get really interesting. When these plates meet, it's not a polite handshake or a friendly nod, it's more of a full-blown wrestling match. When an oceanic plate collides with a continental plate, the denser oceanic plate is forced under the lighter continental plate, a process called subduction. This collision doesn't go unnoticed. It causes the Earth's crust to crumple and fold, much like a carpet being pushed against a wall. And voila! This is how a mountain is born. But what about when two continental plates meet? Well, since they have similar densities, neither is willing to back down. They push against each other until they both rise, creating towering mountain ranges like the magnificent Himalayas. Of course, this process doesn't happen overnight. It takes millions upon millions of years, with the plates moving at a pace comparable to the speed of growing fingernails. A painstakingly slow dance, but one that yields the most majestic results. So, the immense mountains that awe us today were born from the movement of these tectonic plates. The very ground beneath our feet is part of this never-ending geological performance, creating and reshaping the world as we know it. Now, you might be curious, how do these tectonic movements result in the formation of mountains? Well, let's delve into this fascinating world of geological transformations. Imagine two colossal slabs of rock, the tectonic plates, drifting on the molten mantle beneath. Now picture these slabs, driven by the immense forces beneath the Earth's crust, coming together in a titanic clash. The impact of this collision causes the Earth's crust to crumple and fold, much like a sheet of paper would if you pushed its ends together. This crumpling and folding is what forms our majestic mountain ranges. Let's take a look at the Himalayas, for instance. These towering peaks are the result of the Indian tectonic plate colliding with the Eurasian plate. This collision has been going on for about 50 million years, and it's still happening today. That's right, the Himalayas are still growing, albeit at a pace of about 1 centimeter per year. Now let's jet off to South America, where we find the Andes. These mountains were formed in a slightly different way. Here, the Nazca plate is being forced or subducted under the South American plate. As the Nazca plate sinks into the mantle, it melts and forms magma. This magma then rises to the surface, causing volcanic eruptions that, over time, have built the Andes mountain range. But here's the neat part. This process of subduction doesn't just create mountains, it also recycles the Earth's crust. When the subducted plate melts, it forms new crust that can eventually be pushed up to form new mountains. This recycling process is a key part of the Earth's rock cycle and is one of the reasons our planet is so geologically active. So there you have it. The majestic peaks we see are the result of millions of years of these tectonic collisions. These are not just beautiful natural formations, they are living, growing testimonies of the dynamic and ever-changing nature of our planet. So we have our mountains, but how do they continue to grow and change over time? Well, even as they reach their peak of maturity, mountains are far from static. In fact, they are constantly being shaped and reshaped by various natural processes. The first of these is weathering, a slow but relentless process that breaks down the rocks on and near the surface of the Earth. Think of weathering as a sculptor, chiseling away at the mountain bit by bit. It can happen physically, through the freeze-thaw cycle where water gets into cracks, freezes, expands, and cracks the rock apart. Or it can happen chemically when rainwater, which is slightly acidic, reacts with the minerals in the rocks, causing them to weaken and crumble. Erosion is another key player in this process. If weathering is the sculptor, erosion is the cleaner, sweeping away the debris and carrying it off to new locations. This is primarily done by water, wind, and ice. Rivers cut into the sides of mountains, creating valleys, and wind can carry away small particles of rock and soil. Glaciers, too, play a significant role in shaping mountains. As these rivers of ice move, they carve out U-shaped valleys and sharp ridges. Now let's not forget about volcanic activity. In some mountain ranges like the Andes, volcanoes are still very much active. When they erupt, they spew out lava, ash, and other materials that can build up over time, adding to the height and mass of the mountains. All these processes, weathering, erosion, and volcanic activity, work together to mold the mountains into the majestic forms we see today. They might make the mountains appear smaller over time, but in doing so, they also reveal the intricate beauty and complexity of these natural wonders. Despite their solid appearance, mountains are constantly changing, molded by the forces of nature. So the next time you look at a mountain, remember that it's not just a static piece of the landscape. It's a dynamic, ever-changing masterpiece, shaped by the hands of time and the forces of nature. But what happens when the forces that built the mountains cease? It's a question that has fascinated geologists for centuries. You see, mountains are not static, unchanging features of our planet. Instead, they are constantly evolving, shaped by the very elements they tower over. When the tectonic forces that push the mountains upwards falter, a process known as mountain decay begins. It might sound ominous, but it's simply a natural part of a mountain's life cycle. Just as it was built, piece by piece, layer by layer, a mountain is also broken down in the same gradual, meticulous manner. Mountains slowly erode over millions of years, their grandeur chipped away by the forces of nature. This erosion is primarily driven by two elements, rivers and glaciers. Each plays a crucial role in the process of mountain decay, acting as nature's sculptors, carving and shaping the mountains as they please. Rivers, with their ceaseless flow, cut into the mountain's base, carving deep valleys and gorges. Over time, these channels grow wider and deeper, slowly eating away at the mountain's mass. It's a process that can span millions of years, with the river relentlessly gnawing away, grain by grain, boulder by boulder. Glaciers, on the other hand, are nature's bulldozers. As they move, they carry with them rocks and debris, scraping and grinding against the mountain's surface. This process, known as glacial erosion, can dramatically reshape a mountain's landscape, rounding peaks, carving out valleys, and leaving behind unique landforms like cirques and arêtes. This slow but steady erosion is a testament to the power of time and the persistence of nature. It's a reminder that even the most formidable mountains are not invincible. They too are subject to the laws of nature, constantly changing, evolving, and adapting to the world around them. It's a long, slow process, but one that is undeniably happening. Every gust of wind, every drop of rain, every flowing river, and every moving glacier contributes to the gradual decay of these towering giants. Even the tallest mountains are not immune to the relentless work of erosion. So, what have we learned about the life cycle of a mountain? Our journey has taken us from the fiery birth of mountains, forged in the intense heat and pressure of tectonic activity, to their triumphant rise towards the sky. We've seen how these majestic natural monuments grow and shape themselves through the relentless forces of weathering and erosion. We've marveled at the mighty Himalayas, the highest peaks on our planet, born from the colossal clash of the Indian and Eurasian tectonic plates. Their ceaseless growth even today is a testament to the enduring power of these deep-seated geological processes. We've witnessed the Andes, the longest mountain range in the world, stretch across 7 countries, their towering peaks and deep valleys sculpted by the relentless hands of weather and time. We've seen how mountains, like living beings, experience a peak of maturity. At their height, they stand as a testament to the raw power of Earth's inner workings. Yet these towering giants are not immune to the passage of time. They too must face their inevitable decline. Once the tectonic forces that birthed them cease, mountains begin their slow descent back to the earth. The very weathering and erosion that once shaped their impressive peaks now work to dismantle them, grain by grain, boulder by boulder. Throughout this journey, we've learned that mountains are far from static. They are born, they grow, they mature, and they decay. They embody the constant transformation that defines our dynamic planet. Their story is a geological saga written across eons, a tale of the incredible forces that shape our world. Every peak, every valley, every ridge tells a part of this grand narrative. From their dramatic birth to their slow decay, mountains are the ultimate testament to the dynamic nature of our planet.